Yeah, it is. This session would be as follows, followed by with the President, Tejas Networks.
Yeah, good morning, everybody. I hope I'm audible.
Yes, sir. Yes, sir, you are. So before we begin this session, I'll just quickly introduce Mr. Singh to our audience. Dr. Kanwar Jit Singh is Vice President at Tejas Networks. As a Principal Investigator at Bell Labs Research, he worked on VLSI CAD systems and several trend-setting VLSI devices, the first single-chip color CMOS video camera, a multi-processor DSP, and a traffic classification engine. In 2000, he co-founded a startup in the US working to develop a high-capacity core router, which was acquired by UT Starcom in 2003. He relocated to India in 2005 to join Tejas Networks, a leading Indian telecommunication product company focused on optical networks. Dr. Singh holds a PhD from University of California, Berkeley in the area of VLSI CAD and a BTech from the Indian Institute of Technology, Kanpur. We welcome you, sir.
Yeah, thank you for that introduction.
Yeah, and the format of this session would be as follows, that we'll have a 15 to 17-minute presentation by Mr. Singh, followed by a 8 to 10-minute Q&A round with the audience.
Yeah, can you give me presentation rights, please?
Yes, sir. Shrishti, could you please share the host rights with sir?
So the rights are with you.
Okay, thank you. Let me share my screen and let's see if this is visible. If the screen is visible, I just need to.
Yes, sir, it is.
Is the
so we can
is
see
the title slide visible? Okay, great,
yes,
excellent. Okay. So we heard Mr. Dua, and I think he brought out a lot of issues on the business side. My talk, given that I'm from the CTO office, is going to be more focused on the technology aspects and sort of what we can look forward to as we go forward. So there's a few introductory slides which sort of along the, let me move this out of the way. Yeah, okay. So obviously the motivation is clear, right? I mean, we've sort of looked at new ways of entertaining. We've looked at new ways of communicating, instant gratification, a lot of video. So there's a lot of data that needs to move, and the data itself, the video itself consumes a lot of bandwidth, but also there's a lot of analytics and a lot of other things that can be recovered from the video. So there's a lot of compute that needs to happen. And that's really where data centers and high-speed networking and the ability to manage everything centrally makes it sort of the right delivery point for services. Now, as for the location of the data centers, yes, there's a number of different factors. We'll talk about some of them. I think the previous speakers would have covered most of that, but I'll allude to them in passing as we sort of make progress in the presentation. Okay. Yeah, so there is a new Government of India data center policy which sort of wants to reap the benefits of having control of the data. I think this was touched upon earlier, so you can read the content, but essentially what folks are looking at is a lot of investment in the Indian market for data centers. Now, obviously, the location of these data centers, while there is the infrastructure aspect to the data center, one must also appreciate that there's a human capital that is required to run these data centers, and also for the people using the data centers services, they need personnel to essentially take care of their equipment in the data center. So there's a human aspect. And that's why you can see that more predominantly things are urban based, right? So while rural, we do want, but that's where fiberization and connectivity needs to be provided to the rural areas, and data centers may or may not relocate to the data center to the rural areas, depending on the favorable mix of issues there that need to be addressed, right? So from India, there is obviously now a lot of data protection and localization requirements. So that's going to put pressure on the large web-based companies to set up operations in India. There's the government vision of Digital India, a lot of proactive government policies. AI and Internet of Things is always touted as being sort of the next best thing since sliced bread. But we'll have to see how the penetration of this works in the Indian context, given that there is low average revenue per user and perhaps not the same kind of penchant for spending as in developed countries. What's the good news for the Indian market is the growing IT and IT-enabled services sector. These require data centers, a lot of, and also the adoption of cloud services, in particular by all the media houses and the telcos. So all of this is sort of where the capacity is expected to double by 2023, right? So that's a favorable tailwind. It is very clear that data center is sort of a very loose term, and there's a lot of variation in what one views as a data center or the requirements, right? Obviously, budget and for it to be independently profitable is important. There's a lot of insurance building codes. Power has been talked about. Water for cooling has been talked about. To me, one big aspect is also the site safety, right? I mean, the social issues, the security issues. Yes, pollution and other things would be lower in rural India, but there's other factors that also need to be looked at from a security point of view. And in particular, within the data center, obviously, they have to be designed that there is space not only to bring in new equipment, so the logistics outside, but also moving equipment within the data center itself and the weight-bearing capacity of the structures, the raised floors and things like that. But for me, the primary issue, and I think this segment sort of focused on fiberization, really without high capacity connectivity to the data center, it's a piece of unused investment, right? So everything that's happening in the data center is happening because somebody outside needs to consume it. And that's really where connectivity is extremely critical. And the fiber optics has already won over copper. I mean, certainly in the wide area network, but also within the data center itself, we see that there is sort of developments in the copper cabling, but using fiber, you really don't have to worry about whether you're sending a signal at 10 gig or 25 gig or 100 gig, right? I mean, and the distances are also sort of much more controlled. You can go 100 meters at 1 megabits and less than that at 10 gigabits on copper, whereas on fiber optics, it's virtually on a single hop, you can definitely go with low cost optics about 20 kilometers, 10 kilometers is routine, right? So, and there's other factors when we alluded to the weight of the structures that need to be there in the data structure. The cabling actually can be a very significant aspect, right? So you can sort of reduce that. The life cycle, because copper, you need better cabling to take care of higher speeds as the standards evolve. So that's going to limit how long your current cabling will last, right? And energy-wise, also driving electrical signals is over longer distances is takes much more energy than sending light. There is a trade-off there because converting from electrical to optical, you lose some efficiency, but then once you've converted it, you can go a longer distance. Whereas with copper, there is losses along the copper because current is being carried as opposed to photons being transmitted. So we've sort of, the data center interconnect is a very wide space. Within the data center, you can have shorter distances, and that's the intra DC market. But a lot of the focus we feel should be within the connecting different data centers, because that's where you get the amplification in terms of the capabilities. Some services running in one location, some services running in other location. You can combine the outputs of those in another third location, right? It's sort of a much more scalable approach where you can have specialized data centers and then other data centers, which then take the data that's generated within these data centers. That's sort of what's called the east-west traffic in the data center market. The north-south traffic is what comes into the data center and comes in and out of the data center going to the consumers. But within the data centers itself and within multiple geographically different locations, which you can see an example in the Bay Area. Obviously, we don't have, perhaps a similar situation might arise around Bangalore, or perhaps Noida or Mumbai, Chennai, Hyderabad, right? So you would have multiple data centers even within a span of, let's say, 100 kilometers. And then obviously between different cities, and international is obviously the next level, right? Yeah, I mean, intercontinental. But our focus is really in this region where we want to look at a country and a metropolitan area as sort of the two big areas that need connectivity, right? And in the overall, there's also a big difference between how the data center interconnect is spending is there. A lot of in the web scale companies, the Facebooks, Alibaba, Amazon, Netflix, Google, they are really what's driving the data interconnect, right? They are the ones who are the service providers. Whereas in India, it's really, if you look at it, the spending in Asia and in Oceania is really driven by the communication service providers. There is a certain amount of spend done by the content providers, internet content providers, and there are people who are carrier neutral providers who just provide the connectivity to different service entities. So these could be these companies like, for example, Railtel, PGCIL in India, on the on the government side, BSNL also. But there are a lot of emerging carrier neutral providers who are sort of trying to set up the fiber infrastructure. That's the sort of thing in India. So when we look at the data center requirement, what is it that we should be sort of focused on? What are the different aspects, right? One is the bandwidth scalability. Security is important like everything else. We've talked about the desire to have gigabits per user that then scales to terabits in the core. So then really you need switching at those scales. Also, it's very important, the consumers today are very demanding. And so the service agility, the ability to react to changes in the network, the ability to react to certain outages, be it infrastructural or software related, are very important. And then the other thing is that once you've made an investment, you want it to sort of carry on for a long time. So I have a slide for each of those aspects, and I'll quickly run through that. So one thing that most people may not realize is that today between data centers, the signals will carry as something called OTN signals, right? So we've all heard of Ethernet, but really what between a data center, you have some legacy traffic, some data traffic, some storage traffic, right? There are different protocols that the storage teams use, right? So all of this, let's say there is storage remote and you want to access it, right? Now you want a fiber channel connectivity between these two, right? So all of these different signals get combined, and you need a separate type of a framing called OTN, optical transport network, to deliver these signals across larger range, because there are bit errors. The bit errors need to be corrected, because otherwise you won't have any data, right? Data is unforgiving. In voice, if there is a little bit of an error, you can still understand what the person is saying. But in data, if you lose out a zero, or if you sort of flip a bit, that's going to completely change the meaning of the data, right? So error correction is a very big part of this type of a long secure links that are there, right? So we have packet streams, be it radio traffic, be it fiber channel, be it Ethernet. We need to sort of carry it to over a secure location. There's two approaches we can take. We can either do a client or a frame encryption, right? And this slide just sort of gives you a feel for why we are talking about frame encryption. So you can encrypt individual packets. First of all, this is very painful process, because at a high speed, 10 gigabit, 25 gigabit, a packet barely lasts for a few microseconds. And then you need to be able to do all the encryption for that at the headers on a packet by packet basis. Fine, you've been able to secure the traffic, but then you map it into an OTN signal and carry it. In this kind of an OTN signal, people still know at what times are you transferring data, what is the type of data based on the statistics of the packets that you are transferring, right? So there's still information being leaked. Whereas the other way, which is sort of what we advocate, and most of the DCI equipment does it this way, is to take any kind of a client signal, map it into an OTN frame, and then secure the entire OTN frame. The advantage of that is OTN frame periodicity is sort of much lower than the sort of high-speed packet periodicity. So you have more time, and it's a little bit more deterministic, and there is an area for the overheads that need to be communicated to make sure the transmitter and the receiver are using the same set of keys. So this is really a new technology that you need to be aware of. And given that this is the kind of signal that is coming out of every data center, you then need a terabit scale switching to go across the country, right? So there could be hundreds of gigabits over multiple wavelengths coming, and then these need to go to some other data centers. So this is basically where you need innovation in terms of how you build your hardware. And currently the state of the art is to use something called leaf and spine architecture, where you have interface shelves and a high capacity fabric. And we have, at Tejas, we have designs which sort of go from about 800 gig to about 48 terabit. So this is sort of something that is in the background. Most people don't see it, but that's the kind of equipment that you need if you want to build private infrastructure to support a carrier neutral as a carrier neutral provider. Obviously, the telcos already have this kind of gear in their network. And fine, then the other point I was saying is that you need the networks to be software defined. Gone are the days where you had complex node by node control planes. Today, a lot of the data from these individual nodes goes to some kind of application where you sort of figure out where are the faults in the network, what needs to be reprogrammed. So that's really the direction in which the network automation, network intelligence, network programmability, all of those are very important in the data center and the cloud services business. So that's the direction things are going. And this is a little bit of a discussion around specific hardware that you want to use. You want
Sir,
things
sorry
to
to
be.
interrupt you. Sir,
Yeah.
you just have 2 more minutes to wrap up your
Okay,
presentation
I'll
because
just wrap it up. Yeah, so we have basically programmable silicon and programmable software, which allows the service provider to reuse the same hardware they have in different flavors. And for OEMs like Tejas, we benefit because we can do things quickly. So the key takeaways are that the data center build-outs and infrastructure is the cloud service adoption is driving the high capacity DCIs. We talked about the requirements and just want to share with you that Tejas does offer these kinds of products, and we'd be happy to engage and answer questions along that. A little bit about Tejas, and just want to point out that recently we've been sort of acquired by the Tata Group. So we were already a financially strong and innovative company, but now I think there is more that we can do together. So happy to take questions and
thanks, sir, for your presentation.
should I stop the sharing?
Yes, sir, you can.
Yeah.
Thank you so much. So we have around 4 to 5 minutes for questions. So I'll take up the audience questions first. So the first question is, what are the disruptions to reduce power consumption of data centers, both at chip level and in infrastructure, and reduce cost of data centers?
Yeah, so I think that's a natural progression with sort of the miniaturization, and as newer technologies come in, miniaturization helps because we can do more in the same area, and given that it is smaller, it typically runs at a lower power. It can do more in the same area. So I think that really helps drive down the power, and that's one of the main drivers for all the companies to come up with new silicon.
So I'll move to my next question. The next question is more to do with fiberization. So how do you think does the government's BharatNet program be made more effective from implementation perspective, considering the unexpected delay in its rollout so far?
Yeah, so I think it's the BharatNet program is a very, very important program. There is a phase that was done, which was blocked to blocked to the Gram Panchayat. But really, the end-to-end connectivity is then the mandate for the states to take up, and that's where I think things have slowed down. But it will happen. I think most of the next phase of BharatNet work is started. So there's also parallel work that putting the infrastructure and laying fiber is one aspect, but we also need to look at how some of the services that are required in a network, for example, DNS services, for example, certain other security services, will those be shared, and will the government play a role in providing those, or will private operators have to, essentially every small entrepreneur will have to resolve the problem? So I think there is some work in TSDSI to come up with a rural broadband architecture where we sort of may propose what are the commonalities and things that need to be taken up on priority to enable entrepreneurs to use the BharatNet fiber.
So I'll move to my last question now. Last question is, still some tier 2 and tier 3 cities are facing infrastructure issues. Would you suggest any roadmap for fiberization of those locations?
I think fiberization is inevitable, but like the previous speaker said, that it's really an economics issue, and there is obviously policy issues in terms of licensing. There is, I think there is also a lack of coordination, because I see roads dug up all the time in Bangalore, and I'm always wondering why every provider needs to dig up the roads to lay his cable. Why can't sort of there be a more meaningful policy around fiberization? So I think that's the challenge that the government needs to solve. It's a tough problem because of different jurisdictions, municipalities, state level, central level. So, but I think as a country, we need to solve that problem. What is the right solution? I think everybody's clutching at straws for at the moment.
All right, sir. With that, we'll bring this session to a close. Thank you so much, Dr. Singh, for being here with us today. It was really great having you